Hello, this is J. Nickel Investigations, and welcome to a special edition of Ontario Cold Cases, Canada's True Crime Podcast. Today I would like to discuss a massive technological leap forward that police departments around the world are using to solve cold cases: genetic genealogy. Genetic genealogy is a powerful tool that blends DNA testing with traditional genealogical research to uncover family history, identify biological relationships, and trace ancestral origins. It has transformed how we explore our roots, solve mysteries, and even crack cold criminal cases, as seen in the Christine Jessop case featured in Ontario Cold Cases, Canada's True Crime Podcast. Next, I'll explore what genetic genealogy is, how it works, its applications, and its significance, drawing on its role in the Jessop case while providing a broader understanding. First, I would like to thank Sheila.hobeck from Genealogy for her assistance on this subject. Her company website is genealogic.com, KINALYTIC.com. A link will be provided in the show notes. What is genetic genealogy? Genetic genealogy uses DNA test results alongside historical records to map family connections and ancestral lineage. Unlike traditional genealogy, which relies on documents like birth certificates or census records, genetic genealogy examines genetic markers to confirm relationships, uncover unknown relatives, or trace ethnic origins. It's particularly valuable when paper trails are incomplete, as in cases of adoption, migration, or lost records. The field emerged in the early 2000s, when companies like Family Tree DNA began offering affordable direct-to-consumer DNA tests. By 2019, over 30 million people worldwide had taken such tests, fueled by growing curiosity about ancestry and falling costs. Today, it's a cornerstone of both personal research and forensic investigations, as demonstrated in the Christine Jessop case. So how does genetic genealogy work? Genetic genealogy analyzes specific types of DNA to reveal relationships and ancestry. There are three main types of DNA tests used. Autosomal DNA, ATDNA, examines the 22 pairs of non-sex chromosomes inherited from both parents. It's useful for finding relatives within 5 to 7 generations. Example, first to fourth cousins, and estimating ethnic backgrounds. Measures shared DNA and centimorgans, CM, with closer relatives sharing more. For example, parents share about 50%, or 3,400 cm, while third cousins share around 0.78%, or 53 cm. Most versatile, used by companies like Ancestry DNA and 23andMe, and critical in the Jessop case for identifying Calvin Hoover. Y chromosome DNA, or Y-DNA, traces the direct paternal line, father, etc., via the Y chromosome, only present in males. Identifies paternal haplogroups, groups sharing a common male ancestor, is often used in surname projects. Limited to male testers, though females can recruit male relatives. Less relevant to the Jessop case, but useful in other genealogical studies. Mitochondrial DNA, or mtDNA, traces the direct maternal line, mother's mother, etc., via DNA in mitochondria, passed from mother to all children. Identifies maternal haplogroups, revealing ancient maternal ancestry. Both males and females can test, but it's less common due to its narrow focus. This was not used in the Jessop investigation. The process overview. Testing. Individuals provide a saliva sample or cheek swab to a company like Family Tree DNA, Ancestry DNA, or MyHeritage. The analysis. Labs extract DNA and analyze single nucleotide polymorphisms, or SNPs, variations at specific genome positions, to create a genetic profile. Matching. The profiles compared to databases to find relatives based on shared DNA segments, identity by descent, or IBD. Tree building. Genealogists use matches to construct family trees, cross-referencing with records like birth certificates or obituaries. Interpretation. Results reveal relationships, haplogroups, or ethnic estimates, often visualized as family trees or percentage breakdowns, example, 50% African or 25% European. In the Jessop case, Toronto police uploaded the DNA profile from a 1984 semen sample to GED Match, a public database. Genealogists built family trees from partio matches, distant cousins, narrowing suspects to Calvin Hoover, confirmed by a 3 trillion to 1 DNA match. Showcases investigative genetic genealogy, IgG, a subset using similar methods to identify unknown perpetrators or remains. Applications of genetic genealogy. Genetic genealogy serves diverse purposes, from personal exploration to societal impact. Personal ancestry and family connections. Uncovers ethnic origins, connects adoptees to biological families, or confirms suspected relationships. Helps groups like Holocaust survivors or descendants of enslaved people trace lost heritage. Example, Dr. Ann Turner used DNA to trace her family's ancestry and identified genes linked to hearing loss. Forensic investigations, or IgG, solves cold cases by identifying suspects or victims through DNA matches, as in the Jessop case or the Golden State Killer of 2018. By December 2023, IgG had solved 651 criminal cases, including 318 perpetrators and 464 descendant identifications. Relies on public databases like GED Match and Family Tree DNA, where users opt in for law enforcement access. Medical research. Identifies genetic markers for diseases, aiding research into conditions like cancer or hereditary disorders. Example, genetic genealogy databases have been used to study population genetics and migration patterns. Probate and estate settlements, helping to identify, locate, and verify errors where traditional records fall short. When someone dies intestate or with incomplete family records, DNA matching can reveal biological relatives who may have a legal claim. In contested cases, such as disputes over whether a will signer was of sound mind or whether children were omitted, DNA evidence can provide objective proof of lineage. Anthropological studies maps human migration through haplogroups, revealing ancient population movements. Example, studies confirm humans originated in Africa 300,000 years ago, with haplogroups tracing their spread. Social and historical insights deepens understanding of local histories or cultural identities by comparing family perspectives on historical events. Up next, genetic genealogy in the Christine Jessop case. Genetic genealogy in the Christine Jessop case. In Ontario Cold Cases, Canada's True Crime Podcast, of Episode 2 of Unraveling the Christine Jessop Mystery, story of loss, injustice, and redemption. Justice delayed, the fight for truth in the Christine Jessop case. Genetic genealogy was pivotal in solving Christine Jessop's 1984 murder. After Guy Paul Morin's 1995 exoneration, the case went cold until 2015, when Toronto police revisited a preserved semen sample. In 2019, they uploaded its DNA profile to GED Match, leveraging autismal DNA to find distant relatives. Genealogists traced matches to Calvin Hoover, a family friend never questioned in 1984 despite his proximity and knowledge of the Jessop's routines. A 2020 DNA match from Hoover's autopsy tissue confirmed his guilt, though his 2015 suicide prevented a trial. This breakthrough highlighted IgG's power, but also exposed 1984 investigative flaws, like tunnel vision, that overlooked Hoover. The benefits and challenges. Benefits. Extends history. DNA bypasses gaps in records, tracing lineage beyond paper trails. Accuracy. Confirms relationships with scientific precision, as in Morin's exoneration. Cold case resolution. IgG solves crimes where traditional methods fail, giving closure to families like the Jessops. Community building. Connects distant relatives, fostering shared heritage. Now, challenges. Privacy concerns. Using public databases like GD Match raises ethical questions. Post-Golden State Killer, GED Match required users to opt in for law enforcement searches. Database bias. Most test takers are of European descent, limiting accuracy for minority groups. False positives. Misinterpreting distant matches can lead to errors, as in the 2017 Angie Dodge case, where an innocent man was briefly suspected. Emotional impact. Discoveries. Example, unknown siblings can disrupt families, as noted in home testing outcomes. Endogamy. The practice of marrying within a close population over many generations, which leads to individuals sharing substantial amounts of small DNA segments, can make it harder to distinguish genuine genealogical relationships. Pedigree collapse. When the same ancestor appears multiple times in your family tree. Example, distant cousins marrying. It inflates shared DNA, makes relationships seem closer than they are. Pile-up, or recombination regions. Certain parts of the genome are more prone to shared segments across unrelated people, leading to false positive matches. Phasing errors. Determining which DNA segments came from each parent, or phasing, can be imperfect, resulting in mismatches or misconnections during triangulation. Low quality or degraded samples, especially with ancient or forensic samples. DNA degradation can reduce call rates and introduce errors in matching algorithms. Lack of corroborating documentary records. DNA can tell you there's a biological link, but without birth, marriage, or immigration records, it's hard to assign names and dates to those genetic connections. When getting started with genetic genealogy. To explore genetic genealogy, choose a test. Select a provider, example Ancestry DNA or Family Tree DNA, based on goals, ethnicity, relatives, or health insights. Autosomal tests are most versatile. Take the test, submit a saliva sample and await results, typically for 4 to 8 weeks. Analyze results. Use online tools to explore matches, build trees, or estimate ethnicity. Join communities. Engage with groups like the International Society of Genetic Genealogy or Family Tree DNA's projects. Research further. Cross-reference DNA matches with records on platforms like Family Search. For deeper insights, tune into Ontario Cold Cases Canada's True Crime Podcast, where Episode 2 details how genetic genealogy solved Christine Jessop's case. Subscribe on your favorite platform to catch every historical True Crime Tuesday episode. And share your thoughts in the comments to join the discussion on justice and truth. Genetic genealogy is a bridge between science and history, unlocking family secrets and solving mystery like Christine Jessop's murder. Its ability to connect people, resolve crimes, trace ancient roots makes it a transformative field, though it demands careful ethical consideration. Whether you're building a family tree or seeking justice, it offers hope where records fail. Listen to Ontario Cold Cases, Episode 2 of the Christine Jessop story for a compelling example of its impact. And explore your own story, because every family deserves answers, and every ancestor deserves to be remembered. Subscribe now to Ontario Cold Cases, Canada's True Crime Podcast. Episodes available wherever you get your podcasts. Links to all mentions are in the show notes.